Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.34E from the book Thermodynamics in Engineering Approach by Cengel 7th edition. So the statement of the problem is 2 pound mass of water. Mass of water is given to us as 2 pound mass. At 500 psia, initial pressure of water is 500 pound per square inch absolute. Initially fill the 1.5 cubic feet left chamber. This is the total whole chamber. Left chamber is initially filled with water and left chamber is evacuated. So the volume of left chamber which is filled with water is 1.5 cubic meter. It means that initial volume, total volume is 1.5 cubic feet. The right chamber volume is also 1.5 cubic feet. The left chamber and right chamber volume is same, and total volume is V1 plus V2, 1.5 plus 1.5, 3 cubic feet. So, and heat is transferred to the partition is now ruptured. After rupturing, heat is supplied to the system up to 300 degree Fahrenheit. When the partition is ruptured, then the V2 will be total volume 1.5 cubic feet plus 1.5 cubic feet, which is equal to 3 cubic feet, because the volume of right chamber is 1.5 and the volume of left chamber is also 1.5. So total volume is V2 is equal to 3 cubic feet. Determine the final pressure of water and psi. Required is to find the final pressure P2 and psia and total internal energy in the final state U2 and the unit of BTU. Here P2 in the unit of psia. Now we start solution. So first we find specific volume because total volume is given to us. So B1 is specific volume is equal to total volume divided by mass. Total volume is initially 1.5 cubic feet and total mass is 2 pound, which is equal to 0.75 cubic feet per pound mass. It means that initially the volume is 0.7 cubic feet per pound mass. Now we check that whether initially the water is in which region. There are three regions: subcooled region, mixed region and superheated region. So this is the TV diagram, temperature in degree Fahrenheit and specific volume in cubic feet per pound mass. So this is saturation curve. Pressure is initially pressure is 500 psi. This is pressure P1 constant. This is constant pressure line. P1 is equal to 500 psia. Now we will find the point whether the initially the water is in subcooled or compressed region, or in mixed region, or in superheated region. So for this V1 is given to us. So for this we will find Vf and Vg. So from saturated steam table, at pressure is equal to 500 psia, find Vf and Vg. So Vf at 500 psi, This is pressure in psi, a saturated water table, and this is 500 psi. 500. At 500 psi, Vf is 0.019752. 0.019752 cubic feet per pound mass, and Vg is equal to, this is Vg, 0.9282, 0.9282 cubic feet per pound mass. So, and V1 which is given to us is 0.75. So as V1 is equal to 0.75 cubic feet per pound mass is greater than Vf. This value is greater than Vf and less than Vg. Less than Vg. Vf is here. This point is Vf, which is 0.019752. This point is Vg, which is 0.9282. But volume given to us V1 is 0.5. Between Vf and Vg, V1 is equal to 0.75 cubic feet per pound mass. So it means that initially water is in mixed region. So initially water is in mixed region. Mixed means liquid plus vapor region. Now we are finding point 2. So where point 2, finally water is in wet region or in superheated region. So now final state, we are finding final state. So finally V2 total volume is given to us is 3 cubic feet. V2 divided by mass. So 3 cubic feet divided by 2 pound mass is equal to 1.5 cubic feet per pound mass. Now we are finding Vf and Vg at specific volume at specific 1.5 cubic feet per pound mass. So from saturated steam table at pressure at specific volume V2 is equal to 1.5 cubic feet per pound mass. Or also T2 is given to us, so we are finding this is point T2. T2 is also given to us, which is 300. This is T2 final temperature. So it will be easy if I find Vf and Vg at T2 is equal to 300 degree Fahrenheit. Find Vf and Vg. So at 300 degree Fahrenheit, this is temperature and degree Fahrenheit. This is temperature 300. So Vf is 0.017499. 0.017499 cubic feet per pound mass, and Vg is equal to, this is Vg, 6.4666, 6.4 cubic feet per pound mass. Now V is given to us V2 1.5 cubic feet per pound mass. This is also greater than Vf 0.017 and less than Vg 6. This 1.5 is less than 6. It means that so water is finally at mixed region. Mixed. It means that initially water is also in mixed region and finally water is also in mixed region, liquid plus vapor. So we will use saturated steam table. It means that we have to find P2 here. So P2 is saturated steam. So from P2 is saturated pressure. So from saturated steam table at temperature T2 is equal to 300 degree Fahrenheit. P2 is basically saturated pressure, which is equal to, this is 67.021 67.021 psia. This is the final pressure which is required. Now I can show it is, this is P2. P2 is equal to 67.021 psia, and this is initial state and this is final state. We cannot draw the process because we don't know about the process, whether it is adiabatic or isentropic, uh, or isobaric, isochoric, don't know. So for initial state and final state are these, and the mixed region liquid plus vapor. Now we are finding U2 here. We find P2. P2 is here saturation pressure in this region, and we can also find U2 here. So for U2 we will find UF and UG. So from saturated steam table at pressure at temperature T2 is equal to 300 degree Fahrenheit, find UF and UG. As U is not available in this table, so I am using another table to find the value of U. So this is temperature 300 degree Fahrenheit, and this is the value of UF, and this is the value of UG. 269.52. UF is 269.52 BTU per pound mass, and UG is equal to 1100 BTU per pound mass. BTU per pound mass. Now as we know that U2 is equal to, and with the help of volume formula I am finding X2 because X2 is not given to. So as V2 is equal to Vf plus X2 into Vg minus Vf. So X2 is equal to, rearrange this equation, V2 minus Vf divided by Vg minus Vf. V2 is 1.5 and Vg is 6.4666, and unit is cubic feet per pound mass. Similarly, Vg is, sorry, this is not Vg, this is Vf. Vf is 0.017499, 0.017499, and Vg is 6.4666 minus Vf is 0.017499 cubic feet per pound mass. Cubic feet per pound mass will be cancelled. So now simplify this. So X2 will be equal to 0.22988. Now we can find U2. U2 is equal to UF plus X2 UG minus UF. So U2 is equal to, UF is basically 269.52 BTU per pound mass plus X2 is 0.22988, UG is 1100 minus UF is 269.52 BTU per pound mass. So this is simple calculation. Simplify this and find U2, which is 460.43 BTU per pound mass. But we have to find total internal energy. So as we know that specific internal energy is equal to total internal energy divided by mass. So this implies that rearrange this equation, total internal energy is equal to mass and to specific internal energy. So U2 is equal to mass is 2 pound and specific internal energy is 460.3 BTU per pound mass. So pound mass will be cancelled with pound mass and U2 is equal to 2 multiplied by this value, which is 920.86 BTU. So this is the required value of total internal energy at the final state. So this is the end of the problem, and for more problem please like and subscribe my YouTube channel and share with your friends. Thank you.